All right, welcome to part 2 of our section on complex numbers. In this video, we're going to look at dividing complex numbers. But before we do that, we have to talk about what are known as complex conjugates. So if we have a complex number, such as z, and let's say it's in standard form a plus bi, the conjugate of z is just switching this plus to a minus and vice versa, switching the minus to a plus. So the conjugate of z, if z is a plus bi, the conjugate of that is a minus bi. And if the complex number is a minus bi, its conjugate is a plus bi. And we use this little bar above the complex number here to denote the conjugate. So if you're working on the problems and you see a little bar over the complex number, that means find the conjugate. So again, if we have a complex number in a plus bi, its conjugate is a minus bi. If the complex number is a minus bi, its conjugate is a plus bi. So for instance, if we had 5 plus 7i, the conjugate of that is 5 minus 7i, and the conjugate of 5 minus 7i is 5 plus 7i. So you're just switching the sign in front of the imaginary term here, in front of b. So complex conjugates are used to divide complex numbers and also to find complex solutions to equations. So if a complex number is a solution to an equation, its conjugate is also a solution. So they come in pairs there. And if you think it's weird to divide complex numbers through multiplication, well, it's kind of like in biology with cell division and cell multiplication. So. All right, example 2, write your answer in a plus bi form. We're going to divide 1 minus 2i by 3 minus 4i. So I believe this was z divided by w from the previous video. So normally when you do division, you have just actual numbers that you can start dividing, like, long division from elementary school. Can't really do that here. So instead what we need to do is we need to get rid of this I in the denominator, because truthfully it is 3 minus 4 times the square root of negative 1. And we don't want radicals or square roots in this case, even if they're imaginary values, to be in the denominator. So to get rid of it, we're going to multiply the denominator by the conjugate of the denominator, 3 plus 4i. And if we multiply the denominator by 3 plus 4i, we also have to multiply the numerator by 3 plus 4i. So what you do to one, you got to do to the other. So a little bit of calculation involved, but I don't think it's any more difficult than the last example in the last video. So multiplying out the numerator, get 1 times 3 is 3, 1 times 4i is 4i, negative 2i times 3 is negative 6i, negative 2i times 4i is negative 8i squared. In the denominator, 3 times 3 is 9, 3 times 4i is 12i, negative 4i times 3 is negative 12i, and negative 4i times 4i, negative 16i squared. And notice in the denominator, these I terms, the negative 12i and positive 12i, will cancel each other out. And that's because when you multiply conjugates, those middle terms, in this case the 12i and negative 12i, will cancel out. What we have in the numerator, 3, this is going to have a negative 8i squared, is going to become plus 8. So 3 plus 8 is 11, and then 4i minus 6i is negative 2i. In the denominator, minus 16i squared becomes plus 16. So negative 16 times negative 1 becomes plus 16, and then 9 plus 16 gives us 25. So just whatever the denominator is, multiply the top and the bottom by the conjugate of the denominator. And again, when multiplying complex numbers, just watch your steps and take your time. So if we wanted to separate this out in a plus bi form, we just separate it as 11/25 and then minus 2/25 I. Although it's not the end of the world if you leave it like this, but if you want it in a plus bi form, should separate the fractions. All right, so just a real quick rundown of some of the properties of complex conjugates. So if we have z and w are complex numbers, the conjugate of a complex number equals the original complex number. This second property says if we take two conjugates and add them together, it's going to give us the same result as adding the original complex numbers together and then taking the conjugate of that. The product of the conjugates is equal to the conjugate of the product. So again, if we take the conjugate of z, multiply it by the conjugate of w, it's going to give us the same answer as the original complex numbers z and w multiplied, and then take the conjugate of that. For raising a conjugate to a natural number power, like first power, second power, third power, fourth power, etc., it's the same as the original complex number raised to that power, and then taking the conjugate of that. So quite a bit of work if you're going to multiply out a complex number to the third power. It's quite a bit of work. So you'll learn a shortcut in trigonometry. Z is a real number if and only if its conjugate equals itself. So in other words, if you have like 5 plus 0i, then the conjugate of that is 5 minus 0i, which is still going to just give you 5 in both cases. So, all right, that about does it for this video. Thanks for watching, and I'll see you.